Hi guys, so the problem in discussion today is from the recent August Cook-Off and the problem name is different string. So the difficulty level of this problem is easy and its prerequisites are set and decimal to binary conversion. Now let us read the problem statement. So starting off with the problem statement, we are given n binary strings of length n each. We need to find a binary string of length n which is different from all the given strings. So this is a pretty short problem. Note that a binary string is defined as a string consisted only of 0 and 1, and a string is called different from another string when they differ in at least one position. So let us say we have input that given n is equal to 3. We are given three binary strings, say 101, 110 and 001. So now we need to give output a binary string which is different from these three and has length n. So obvious answer is 000. So 000 is acceptable answer for this case. There is nothing much to say in the sample case really over here. So now let us directly proceed to the solution approach. So starting off with the solution approach, first let us see why the answer will always exist. So we have been given that n is between 1 to 100, right? So the minimum value of n will be 1 and the maximum value will be 100. Now let us see why exactly the answer will always exist. So look carefully over here. So we know a binary string of length n has how many possibilities? 2 to the power n, since each position has two possibilities. Therefore, a n length binary string has a total number of possibilities of 2 to the power n. Now, we have been given n strings. So the number of strings that are possible is 2 to the power n minus n. So this will always be greater than 0, since 2 to the power n is always greater than n, right? Therefore, the answer will always exist. That is, there will always exist such a string which is different from the given n strings. Okay, so this is the proof of why the answer will always exist. Now let us see how we can find the answer. So here we will be using something called the pigeonhole principle. Now what is exactly the pigeonhole principle? So say you have say 10 holes and you have 11 balls. So with this information we can definitely say that if we want each hole to have a ball, then there will at least be one hole with two balls, right? So this is what the pigeonhole principle basically says. Let us see how we can apply it over here. So we have the maximum, so we have n given to us. So n is between 1 to 100. Now we have total of n strings. Now let us consider all numbers from 0 to n. So how many numbers are these? So these are n plus 1 numbers, right? So if we convert these numbers to their binary representation, then we will have n plus 1 distinct strings. So now we can always do that when a number is converted to its binary representation. We can always convert it to a certain length number. So say I have say 7 and I need to convert 7 to its binary representation, say 111. Now I want to convert this to a length 5 number, length 5 string. So basically I can add two zeros at the beginning and here I have a length 5 string. Now here I have n plus 1 strings in such a way of length n. So if we check all of them in our given set, there will be at least one such string which will not be present in our given set, because our given set, so this is our given set, it has n strings, right? And the set that we are checking it against, it has n plus 1 different strings. So there will at least be one such string which is not present over here, right? So that string is our answer. So what we have to do is we have to just iterate from all numbers from 0 to n, convert them to binary. So we have to convert them to binary string of length n, and then we have to do is check if it is present in our given set. So check if present in set. So if it is present, then we'll move to the next string, and if it is not present, then we will simply print it, right? And then we will break off the loop because we have got our answer. So this is basically a short pseudocode of what we are going to do. So I think you have understood the solution, and now let us directly go to the implementation. So starting off with the implementation, first I took input n, which is the number of strings and also the length of each string. Next, I initialized a set, a string set. So in this set, we are going to insert the strings. Now here I am taking input the n strings that will be given as input, and I am inserting it in the set. Now over here, what I am doing, I am iterating from 0 to n. So these are a total of n plus 1 numbers. Now what I'm doing, I'm initializing int num is equal to I, and I'm converting this num to its binary representation. So this string bin will be its binary representation. So binary representation is simply while num not equal to 0, bin plus equal to, I will convert this to string num mod 2, and then I will just do num is equal to num by 2. So this operation converts it to its binary string, but this binary string is in its reverse state, so we will reverse it again. So now we have the binary representation of num in our bin. Now we have to make it of length n. So how we will do it? First, let us see what is the size of our current binary string. So let us say our current size is cur. So cur is equal to bin.size. Now I will initialize a string result is equal to n minus cur, that will be the length of the string with all zeros. So this will be the leading zeros of the string. So with n minus cur leading zeros, I will just append the string, the binary representation of num to this. So res plus equal to bin. So now we have created our n length string. Now what we have to do, we just have to check if our resultant string is in our string set. So here I just do if st.find res equal to st.end. So this is just a boolean operation. So if this gives us the result true, that means our string res is not in the set. So if it is not in the set, we will just print result and we will break. So this operation is bound to give us the answer. That is why I'm not writing any else statement over here. So after we have done this, so this is the like we have finished the code, and this will definitely give us a AC. So this was the code, and I think you need to have the observation of trying to make string from 0 to n, and once you get that, I think it's pretty easy to code it. So yeah, thank you, and let me know if you have any doubts.